going to be a little bit different lesson. We're going to be doing some things. A lot of this stuff we've talked about before. Some of it we haven't. So some of the things that we're going to talk about today, and we're going to use a different terminology or a different way of expressing certain things. So our big topic today is domain and range. And so we're going to talk a lot today about a couple of vocab words to start with. And one of the first ones is domain. It's a word that we've heard of before. We do it a lot in Algebra 2. Find the domain of a function or of a graph. Domain is your set of input values. Typically, that will be x. X is the variable that we use most of the time for that. But if you have like a story problem, it may not always use x and y in the equation. And so it's whatever we're putting into the function. And then range is the set of output values. And we usually refer to that as our y value. Just to kind of give you an example of what we're talking about here. On Friday, we talked about a real basic function, like y equals 2x plus 3. Okay? So if I wanted to generate a set of ordered pairs or a table of values for this, then I could plug a number in for x, like let's say 0 would be a really good number to plug in. 2 times 0, 0, 0 plus 3 is 3. So my input is 0, my output would be 3, and that would be an ordered pair, 0, 3. And then we could plot that ordered pair. So we put something in, we get something out. Okay, another vocab word for today is function. Each member of the domain matches with exactly one member of the range. And one of the things that I like talking about here is the x value cannot repeat. Sometimes it might be a set of ordered pairs. Sometimes it could be a table of values. Sometimes it might just be an equation. And we got a lot of different ways that we're going to determine if a relation is a function. But the biggest thing that we're going to ask ourselves is, does the x value repeat? We're going to determine it both, sometimes off the graph, sometimes off an equation, sometimes just by looking at some ordered pairs. So if I had, let's say I had a list of the only values that I care about are those values right there, okay? In this case, all three of the x values are different, so we would say, yes, this is a function. All the x values are assigned to one different y value. If if I did 2, 3, 4, 5, and then 2, negative 6, now because these 2's repeat, we would say, no, this is not a function because the 2 repeats. So if I'm just flat out given a set of ordered pairs, all I have to do is look at the x value. The y value doesn't really matter. It's really the x value. Does that x value repeat? Okay. We'll talk about how we can do it graphically and looking at functions as well. But that's what we want to pay attention to. Okay, evaluate a function. So first up, what we will see a lot in college algebra is we will not see a lot of equations written as like y equals, like we saw that on Friday a little bit. We're going to start to see function notation, and we've seen this before. It's just the notation or the way that we write an equation. And there's reasons for this, but this would be what we call function notation. The f of x simply just replaces the y value. The y value no longer is there, okay? It's the same thing, and I could rewrite this as y equals x over 2 minus x. But one of the purposes of using function notation is because if I wanted to generate a bunch of outputs, like if I wanted to come up with a bunch of ordered pairs or find out what the value of certain things is going to be, then using function notation makes it a little bit simpler. Okay, and the easy way of doing that would be if I said, what is f of 2? Which means I want to generate a value by plugging 2 in to this function. This is probably not the best one to start with, but watch what happens here. I put 2 in wherever there's an x. Because we're generating f of x is 2, the x is replaced with the 2, right? So when I do that, now we're going to simplify this or evaluate it. So on bottom, 2 minus 2 is 0. This is why it's probably not the best one to start with. But what happens when I have 0 on the bottom? Okay, try putting it in the calculator. We would think it would be 0, but watch what happens. Take 2 divided by 0 in your calculator. What's your calculator? Error, right? Should give you an error message. We cannot divide by 0. Okay? If I gave you a pizza and I said, hey, we're going to take that pizza and we're going to cut it up into 0 slices, can it be done? Because we already have the pizza, right? The pizza's already there in front of us. We already got one big slice would be the whole thing, right? I could cut it into 2 big slices or 4 slices or whatever, but I can't cut it into 0 slices because we've already got the pizza there in front. So you can never, ever divide by 0. Okay, so in this case, we would say does not exist because you can't divide by 0. You can never, ever have 0 on the bottom. Okay, that's a little bit different than I'll do just the opposite of this. Let's say we plug in 0. 0 is a number we like to plug in a lot of times. So all we're saying here is let's evaluate this function at 0. Let's plug 0 into this function. That's all we're saying. Okay? It's just a real fancy way of saying it, and it's a really quick and easy way of saying it. That's why functional notation is easier here. So I'm going to take 0, I'm going to plug it in, and what I have here is I have 0 over 2. Well, this one's different because 0 is on top, not on bottom. And if I take 0 divided by 2 in my calculator, what do I get? This time it's 0. Okay? It's okay to have 0 on top. But if I had 0 and I try to slice it up, I can't slice it up into two sections and try to divide it by 2, okay? Can't do it. So when 0's on top, my answer is always 0. When 0's on bottom, we would say does not exist. Can't do it. Impossible. We could do let's do f of 9. We can plug in whatever number we want. So here, I would do 9 over 2 minus 9. We're just going to simplify it, and then if we try to decide how am I going to leave my answer here, it's okay to leave your answer in fraction form. I really don't want you to, especially for this one, to change it to a decimal. This would be the best way to leave it. You don't have to change it to an improper fraction or a mixed fraction. An improper fraction is perfectly fine. It's okay for the number on top to be bigger than the number on bottom. There's nothing wrong with that, okay? So that would be the quickest and easiest way to leave that answer. Don't try to change it to a decimal, because then we're worried about, like, what are we going to round it to? What's our decimal going to look like? Okay, another one here, just to kind of give you a little bit of a taste of everything here. If I said, what is f of m? So now we're going to take m and put it in for x. Wherever there's an x, we put in m. So it's not a number anymore. Now it's a variable, right? And if we try to look at how do we simplify this, well, we can't, okay? And I'm going to tell you right now, okay, one of the biggest mistakes that people make in college algebra or really any algebra class is they just want to knock those m's out. Can't do that here. Because down here, they're connected by either a minus sign or a plus sign. In this case, it's a minus sign. 2 and m are connected together. In order to knock it out, I would have to have a 2 minus m on top as well. So it looks a little bit weird, but this is as far as we can go. That's as much as we can simplify it. Now, if I had something like m over 2m, and there's no plus or minus sign, in that situation, it's okay to knock the m's out, okay? But that plus and minus sign links those together, and that now makes it not able to simplify, okay? So a lot of different little rules and things like that we got to remember with algebra. When can we simplify versus when can we not simplify? So that just gives you an idea of some different types of evaluating that we could do. We can evaluate with numbers. We can evaluate with variables. Our answer is going to look a little bit different depending on how we do that. Okay. We talked about domain and range is a really big topic today. You're going to have some questions today that are going to say, identify the domain or find the domain from the graph. And so they're going to give us a function to graph. This is where your graphing calculator is going to come in helpful, okay? And you're going to put it into your calculator, and then we're going to look and see what would my domain be here. And we'll talk about how we can determine that. I'll give you a function. Okay, if I said f of x equals, and this is not one that we did on Friday. We're going to graph some functions that we didn't graph on Friday. That's why we're going to rely on our graphing calculator a little bit here. X cubed plus 2. First thing we're going to do is we're going to put it into our calculator. We're going to graph this function, and we're going to look at the graph, and we're going to try to determine visually what would be the domain of this function. In Algebra 2, you would have said all reals. And that's okay. That's still right. It's all real numbers. Everything's possible. It's going to extend from left to right forever. But in college algebra, we have a different way of writing that. Okay? And we're going to use what we call interval notation. And for this one, we would say that this graph is going to extend from negative infinity to positive infinity. It's going to extend all the way to the left, and it's going to extend all the way to the right. What that means is, if I draw a graph up here, and I know this is my x-axis and domain is referring to the x values, right? All the way to the left on the number line would be negative infinity. All the way to the right would be positive infinity, because this is the positive side of the coordinate plane, okay? So it's going to extend all the way to the left, it's going to extend all the way to the right, so negative infinity to positive. All real numbers is another way to say that. Okay? Everything's possible. The two graphs that we did on Friday, linear equations, quadratic equations, are the same way. Those are both also all real numbers for our domain, every time, okay? So if we just simply ask you for the domain, we'll do some that do range as well. We'll talk about range a little bit here today. But you will have some that just ask for the domain. The domain's probably the most common. Okay, let's try this one. F of x, or let's do a different one. Let's go g of x. Okay, so we're going to graph the square root function. I'm just giving you a couple of different types of functions that we didn't graph these on Friday as well. So these are totally different functions. I'm not expecting you to graph them by hand. That's why we're going to use our calculator to help us out here. Make sure the -1 is not underneath the square root. So when you go to your calculator here, so what we would say, and this one's going to be a little bit different, because we're including 0, because there's a point at 0, instead of using a parenthesis, we're going to use a little bit different symbol here. We're going to use a bracket. And we're going to start at 0, and we're going to go to positive infinity. Okay? So a bracket means that it is included. A parenthesis is not included. And the same thing could be on either end. Oops. And I'll look at some different examples of those today as well. When do we need brackets and parentheses on the left or on the right? Okay, questions on that so far? Okay, once again, the directions here, I'm going to ask you to, and we're going to see some that are going to ask this question, find the domain. And the way that we wrote this in Algebra 2 is going to be a little bit different than how we're going to write it today. Okay? In Algebra 2, we tried to find like what is restricted. And what we talked about here just a few minutes ago is, because we have a fraction, what number can we never have in the bottom of a fraction? What can we not divide by? 0, right? We cannot divide by 0. So the denominator here cannot be 0. What value of x would make the denominator 0 here? 2, right? So what we would say is that x cannot equal 2. X can be any number I want it to be except for 2. X can be any number that we want except for 2. Okay, that's probably how you wrote the domain in Algebra 2. You might remember that. Okay, so I'm just trying to draw some similarities here from the way you've done it versus how we're going to do it now. So now we're going to put this into interval notation again. Anytime that we talk about domain and range from here on out, we are going to put it into interval notation. We're not going to write it like this. Is it the same thing? Yes. But when it talks about domain and range, we want to put it into interval notation. The reason I tell you that is because you're going to have questions that are like multiple choice. And that's how the book is going to write it. That's how they're going to express it. So we need to get familiar with that. We need to be doing it the same way so we're familiar with that when we see that. Okay, so what we're saying here is every number is possible except for 2, right? So here's how we write that. a few minutes ago, we said negative infinity to infinity includes everything, right? Well, here we're including everything except for 2. So we're going to start at negative infinity. We're going to go up to 2, but we're not going to include 2 because 2 can't be part of it. Okay, and then here's the part that's a little bit weird. There's a gap there because we have a gap at 2. And then we're going to start over again and go from 2 to infinity. So what this does is this shows that there's a gap in the graph. Okay? If you graph this in your calculator, then there would be like an asymptote. We talked about asymptotes way back when, but there's going to be like an invisible line right there. Your graph is never going to hit 2. And I want to show you something. And this is good just to know, like on your calculator. This calculator is a little bit different, so don't be afraid to ask. Okay, if you would get out your textbooks, we're going to do a couple problems, and the only reason sometimes I think it's easier just to look in our textbook than me drawing a picture of some of these things, and that's going to be the case here, or you can share with a friend if you don't have yours with you by chance. Okay, we're on page 28, number 42. We did some problems like this at the beginning of the lesson today. But there's one big difference here. Okay, it's asking me to evaluate 3 values, but they don't give me the equation or the function. They don't say, hey, g of x equals this. It just gives me a function. It gives me a graph. So the graph is drawn, okay? Now here's what we have to remember. This number represents what? When I say evaluate g of negative 2, what number is negative 2 really the same as? If I write like g of x, if I write function notation, right? What number is always in the parentheses? It's our x value, right? So this number represents our x value. What we're trying to figure out is our output. We're trying to figure out what is g of negative 2 equivalent to. But we don't have an equation to plug it into, so we can't evaluate it that way. So we're going to use the graph to help us evaluate. So if we look at the graph of number 42, what we're looking for is where does negative 2 have an x value, and what is the y value associated with that x value? So find negative 2. What y value is associated with negative 2? 4. So all we have to do here is say 4. This is just another way of rewriting this ordered pair. Negative 2, 4 is the same as g of negative 2 equals 4. This is my input, this is my output. Okay? There is no equation to plug it into, so we can't do it that way. What about g of 0? What y value is associated with 0? Negative 4. And finally, this one looks hard, right? G of 2.4, well, how are we going to do that? Just look at the ordered pair and look at the ordered pairs that they give me. If they give me 2.4, the y value associated with it is negative 2.6176. So there's no math involved there. It's just another way of evaluating a function, but this time without the actual function. And it will give you the ordered pairs, right? You might say, well, how are we going to evaluate any other thing? We can't evaluate any other thing because we don't have the equation to evaluate. You're going to have to evaluate it based off the ordered pair. Okay, so not a lot of work involved, but just understanding what it's asking for. in that scenario. Okay, another one I want to take a look at in your book is, let's look at number 68. Next page. This one is asking me to identify the domain and range of the function. Okay, and the reason I have you look at your textbook is so I don't have to redraw this picture, and I think it's a little bit easier to just look at it. But remember that domain represents x value. So the question that we're really asking ourselves is how far does this graph stretch from left to right? Okay? So how far left does this graph go on the x-axis? -3. Okay, now what you'll notice is at -3, the circle is a closed circle. So the symbol that we want there is a bracket. We're including -3 because there's a closed circle there. And we're going to keep moving to the right until we get to what? 5. So we're going to put -3 all the way over to 5. 5 has an open circle. So we're not including it, so we want a parenthesis. So there's where you're talking about included versus not included. Closed circle means bracket, open circle means parenthesis. That's my domain. All values from -3 to 5, including -3. Range is going to move up and down. Okay? Range is the y values. So what we're asking ourselves here is how low on the y-axis does that graph go? We're not looking at x values here. So how low does it go on the y-axis? -4. Okay, and we're going to put a bracket there as well because we're including -4. It goes down to -4 on the y-axis. How far up does it go? 1. And that one's an open circle, so that would be our range. Domain is going this way. Range is going this way. Okay? You guys see the difference between that? And we don't want to use infinity on that because there's no arrows. It doesn't keep going forever. Okay? Infinity is only used when the graph goes on forever in either direction. Okay. Another one from your textbook. You'll have a couple like this. Let's look at number 76. This is another graph that we did not talk about on Friday. You're going to see a lot of different variations of equations or functions today. And all you're doing is putting those into your calculator and using the calculator and the graph to visually identify the domain and range. Okay? So it's asking me a couple of things. Graph the function with a graphing calculator, then visually estimate what your domain and range is going to be. Okay, I will tell you this, and this is another reason why I picked this one. The absolute value function in your calculator is kind of hard to find. Okay, so here's what you're going to do to graph this one. You're going to go to your y equals. Okay, you're going to go to math. This is if you have a TI calculator. Okay, if you have Casio's, I'll have to show you where it's at. Then you're going to go over to num, and then you're going to go to ABS. Okay, if you're on a Casio, you'll go to graph, and then you're going to look for different kind of functions, and you're looking for the ABS button on your Casio. ABS is absolute value. If you have an older calculator, when you hit enter for ABS, it's going to just say ABS parenthesis. Some of the newer calculators actually put the vertical bars in there, so that some of the older calculators don't have the graphics to put the vertical bars in there. So if it doesn't put the vertical bar in there, that's okay. Okay? So you're going to rewrite this into your calculator, and you should be able to have it look like that. Or if it doesn't put the absolute value in, it'll say ABS and then parenthesis, and then you're going to put X in and close the parenthesis off and then do the -2. Anybody need help finding that on their calculator? Anybody need help finding that? Everybody found the absolute value button? It's hidden in there. Okay, so if we graph this one, if you go ahead and hit graph, you're going to get a graph of a V, and it's going to kind of look like this. Okay, so we're using the graph in our calculator to identify the domain and range. How far left and right is this graph going to go? Infinity, both directions. And so we're simply just going to say negative infinity to positive infinity. It moves on forever. All real numbers is the other way that we say that. Okay, range goes up and down. How low are my y values going to go? -2, okay. How far up is it going to go? Infinity, okay. So my range here is going to start at -2, and it's going to go upwards to infinity. Okay, the biggest thing, and I always like to think domain versus range, right? Left to right versus up and down. So there's a big difference between those two. Okay, I think that covers everything we need to talk about. Okay, assignment for today. Okay, what the by 5 means is because there's so many problems in these sections, then I don't like evens and odds because I try to get a lot of different variations of problems. So we're counting by 5s. So we're going to start with number 15. And the next one we're going to do would be 20 and then 25. So we're just going to keep counting by 5s until we get up to 55. And then at the end, 70, 75, and 80. Sometime we'll go by 5s, sometimes we may go by 3s or 4s, just depending on the section. But today we're going to go by 5s. Make sure you read the directions carefully on what you're doing on each one and what you're trying to do. Yeah?
When we get homework done, do we just put it in there?
Yeah, so you can just hang on to it. You could actually just keep it in your notebook. And then like on Thursday or Friday, I'll come around and take a look at it, and then I'll just give you your grade all at the same time. Okay? I will post answers so that you can kind of check as you go. So today, I'll post answers to Fridays, and then I'll post answers to today's as well. Okay? But yeah, that way you can just keep it right there in your notebook. What's that? Sure. Let me go. Does anybody else need a calculator to borrow?
That means it can keep going.
No, he was doing it.
That's not how the subject works. Okay, sometimes it is for me and sometimes it isn't. Sometimes math, we can get it out in two sides. Are you my national honor society? No. My mom forgot to do that. She forgot to do the paper. Oh, and I forgot about it. You're like, I really had to do it.
This is so good.
She had to like, and I was like, I don't really care. She was like, oh, you could have. And that bucket. Good golly. She's not just because that is a real Ashton coconut.
No, I like
Non-function or something. I'll get it. I'm so
If it's not a function or something,
I'm gonna raise for it.
You would still do the domain and range, but then you would just say not really.
I love you so much, but I'm gonna fight for that. What's your backpack? I'm just like gone.
Guys, you should go on the other side.
Nah, we just had more heart.
Well, yeah.
Oh, yeah, I saw that.
Because my team didn't have like
I was like,
no homophobia, just like around the world.
Sorry.
All directions.
Huh?
So,
Hey, don't say so.
yeah.
No, really just hit on the ground really fast.
Yeah. Especially like you can grab like there's some.
Personal finance?
Yeah, no, I'm not gonna say.
I heard the personal finance is hard. Yeah, she is. I don't know. They know most of my class. It's probably where it's from. Said that it was under so I have last year. Me too. That's hopefully 18 minutes.
Oh,
Abby keeps telling me
you see that one short is like, yeah.
I like that I'm sorry.
Big Brian's good.
I thought it was more to be like shorts are a little
Yeah,
high.
Oh yeah, I don't know. It's actually.
That's my thing.
Were you suited up varsity in my freshman year?
Wait, was not.
Oh wait, that was my freshman.
Yeah, that was your freshman.
Why was I was in the.
See you guys. Have a great day.
Oh, that was it? That's when you guys had a plan?